So in this lesson, we're going to introduce the idea of computational thinking and the different aspects of it. So while we go over computational thinking briefly in this lesson, we will explore it more fully and more in depth as we move through the course and really apply these different skills to different aspects of problems as we encounter them. So our goal today is to understand the methods of breaking down problems into parts using computational thinking and potentially thinking tools like mind maps. Why? What's the point? It's so you can break down problems into small related chunks that can be solved easily. When you're given a problem in this course, they could be big problems. They're too hard to solve in one step. But if you know how to break a problem down into a number of smaller steps, then you will quite easily be able to solve the smaller steps. And through solving the smaller steps, the small problems, you'll actually solve the big one. So the big problem will be actually solved once you've broken it down. We want to work out any patterns that exist so you can just simplify the requirements of the solution. So for example, if you're given a problem and you find that there's a queue of customers and they keep doing the same thing over and over and over again, well that's a pattern. So you only have to solve one instance of the person interacting with that particular item, and then you've solved it for everyone by noticing a pattern. We want to be able to generalize a problem. And that means we want to be able to focus on the most important aspects. Because when we deal with and solve problems, 80% of the value of the solution is actually going to come from 20% of the features. In fact, if we work out the right 20% of the problem to solve, we'll actually probably come with a solution that is more than satisfactory in the first place. We just have to work out what really needs to be solved. And then we want to be able to eventually determine step-by-step methods or procedures to solve a problem or an algorithm. And that's where we'll really get into the computational side of things, when we just actually want to work out things one step at a time, because that's how computers think. They can just do one small operation at a time. And it's the sum of those small operations that actually helps us solve a problem. And so our success criteria, well, if you can provide a thoughtful description of all the parts of computational thinking, you're sweet. If you can just provide something that's appropriate, like you've got the main thrust of the ideas and you can kind of apply them, then you're doing it right. If you can only kind of describe them, so if you can like identify and kind of describe what they're about, that's okay. But what we're really after is you to be able to use the skills or demonstrate some knowledge of how they are used. So let's just get into it. So to kick off with, computational thinking. So computational thinking, it's a problem-solving process that's usable by everyone, a variety of content areas and across many everyday contexts. You've probably used it yourself already. Like when you encounter a problem, you use computational thinking. When you sit in the maths class and they give you a problem to solve and it's a worded problem, well, you use computational thinking to solve that problem. You work out what are the main points of the question, what are the main important numbers, what patterns or problem-solving techniques do I know to solve this problem, and then you just go through the steps of the problem. You apply the algorithm. So you've used computational thinking all the time. It's about breaking things down into smaller parts to find similarities, to identify the relevant information opportunities, so we can simplify and create a plan of action so we can actually solve this problem. So the first part of computational thinking is decomposition. So what's decomposition about? This is the breaking down of problems into smaller sections. We want to make these complicated problems that we're dealing with, and I use the word complicated kind of loosely because they're not going to be huge problems, okay? We're not going to build Facebook. We're not going to build Google. We're just going to build small systems, okay? So they're complicated, but they're actually very manageable by you. We're going to take those complicated problems and we're going to break them down into really small parts. So that's the thrust of decomposition. It's to address computational thinking in a simple way. So real world examples. So your parents come in and you say, you know what, I want you to clean your room. And you walk into your room and, well, it's a disaster. There's stuff everywhere and you don't know where to start. The problem is too big. So what do? You sit down and you actually break down the problem. Okay, I'm going to deal with my desk first. I'm just going to tidy up the papers on my desk and I'm going to put the pens in the right place. And then I'm going to go over to my drawers and I'm actually going to fold the clothes instead of dumping them on the floor. And I'm going to put them away neatly and sort them out. So you actually just tackle one small part of the room at a time. And then you go to the bookshelf and you just sort the books out and you tidy the books up. And after you've done 3 or 4 small jobs, you suddenly look around and the room's done. So by solving the small problems, you actually solve the big one. So when we decompose a problem, we really want to do some questions. We want to say, what are the different parts of the problem we're trying to solve? We want to break the problem. What are the key aspects of the problem? What sections or things can I think about individually? And we want to describe those sections, and then we want to think about those sections themselves and how can we break them down into smaller parts. So let's consider an example. Let's think about making breakfast. How can we achieve this, and how can we present this information? Could we use a mind map? And that's actually what we're going to use. We're going to use a mind map. So I'm going to use a program here called FreeMind. Now at school you can download this. It's on Case. It's a good mind mapping program. You can use any mind mapping program you want for this course, but you will be needed and will be required to produce mind maps. That's just how it goes. Okay, so we're going to make breakfast. So I'm just going to automatically format this. So I'm going to what are the parts making breakfast? Well, I suppose I don't need to decide what to make for breakfast. So let's just decide we're going to have the eggs on toast. So we need a process where we get the ingredients. Okay, and after getting the ingredients, there's going to be another process, and that's going to be getting the equipment that we need. So the knives and the pots and stuff. And then we're going to need to set up the stovetop. Then we're probably going to need to do the actual cooking. And there'll be some type of cleaning process. And also there'll be some type of eating process. So actually making breakfast consists of a number of different processes. So I'm just going to reorganize this page a little bit. If you're using this program, I'm just holding down Control and hitting left arrow to flip things over. And now getting ingredients. What's involved in getting ingredients? Well, when I get ingredients, I need to get the eggs. I need to get the bacon. I need to get the bread. And I need to get the orange juice. Okay. Okay, now I need, what equipment am I going to need? I'm going to need the fry pan, your plate. I'm going to need a spatula. What else am I going to need? I'm going to need maybe the toaster. And I'll probably need a cup and some cutlery. Okay, so that's the process of getting. So I've broken this down. I'm decomposing the problem. So I started with this problem: make breakfast. Now I've got 6 different subtasks, and each one of these subtasks has smaller subtasks, and each of these ones is really manageable. I can get the eggs and bacon and bread and the orange juice. So I can solve them, and then suddenly I've solved get ingredients. And I can go into the oven and I can get to the cupboard and get the fry pan and the spatula and the toaster and the cup, and I can get all those things. And suddenly I've got the equipment. Then I've got to set up the stovetop, so that's going to involve turn on the oven. Set the temperature, and I probably need to put the fry pan on. Okay, so that's the process of setting up the stovetop. And then the cooking, well, that's another process I can do with individually. So when I cook, I need to add the eggs to the pan, add the bacon to the pan. Probably need to check if they're ready. If they're ready, I probably need to take them off, take off the heat. When it's done, need to remove the items, the egg and bacon, bacon. And also, I was also going to make the toast. I'm going to make the toast. I'm going to make the toast. I'm going to put, let's say make toast. Now making toast by itself, that could be a whole heap of other steps. I mean, that could be like put toast in toaster, set temperature, the timer, pull out when ready. I probably also, spell correctly. What else? Oh, I probably want to like turn the toaster on. Those things are important. Okay. And then I've got to clean up and I've got to eat it. Okay. So, just like put everything in sync in dishwasher because I'm gonna be lazy. And then I can eat. So I've decomposed the problem of making breakfast. And what did I do there? How did I do it? It's more about the process we're interested in of decomposition, because that's a process. I broke it down into different steps. And I took those steps and I broke them down into smaller ones. So that's kind of how you decompose. You can build a mind map and then solve all those individual tasks and you're ready and you're good. So maybe we could have you think of problems now. If we were going to make a mobile phone application, okay, and we wanted to be able to have our application scan QR codes. So think of different applications we've had to scan. There was the COVID application, the check-in, where you had to go and scan the locations you were visiting. Imagine you're making that application. Well, what type of things do you need to have? You need to have some type of user interface that can do certain things. You need to access certain features. Have a think. Try and put together a little bit of a mind map of how you can make an application to generate a QR code.